Okay, good morning. Yeah, I'm here to talk to you about performance and flexibility improvements that we made in our Magnolia setup. I'd love to tell you about them, and hopefully some of you can make use of these things, maybe now, maybe in the future. I'm a Java developer at VPRO, which is one of the public Dutch broadcasters. We do television, radio, print, and yes, also online media. Actually, we have been doing this for quite a while. I've been with them since 2008. They've been online since 1994. Back then it looked like this. This is not Magnolia, by the way. They even proceeded to build their own CMS, but because back then you just didn't go to WordPress.org and download a ready-to-go CMS. There was nothing like it. So they built their own. They actually even used Java before it was called Java, apparently. So we're still a Java shop over 20 years later. And since 2010, we've been using Magnolia. We are still migrating websites because since 1994 we have been creating lots and lots and lots of content. But our main sites have been on Magnolia for 6 years now. And we're very happy with it because it allows us to easily extend the core engine, as we call it these days. But having been building sites for so long and having probably over 100 or even 200 editors creating content every day, that means you get lots and lots of pages. And luckily, you don't have to physically store them, but still in the digital world, that can still be a problem. And we have multiple sites like that really have tens of thousands of pages created. They might not be requested every day, but we still want to keep them around for whoever wants to look at them. We're not a news site, so it's not like a week later, it's not really relevant anymore. There might just be a nice video of a great performance 15 years ago that you might want to watch again. So we want to keep it around. Sorry. And if you create pages, of course, you want people to be able to browse through them on your website, and that means creating listings of your content. And of course, you're not gonna make a single listing for all the pages on your website, so you have hierarchies of overview pages, and there's gonna be lots of those. You might separate it out by year and maybe a month or topic or whatever, but still there's gonna be lots and lots of them. And yeah, hundreds maybe per site. And then one day we noticed this in the logs. I hope you've never seen this, but yeah, go check your logs if you're back home, because we didn't really notice. This wasn't not like every time we request an overpage it would take a minute. Of course you would notice, but if it's happened sometimes, then that's already a problem. And luckily we have page caching, so once the page is rendered, it is in the page cache, and the next person to request the page won't have to wait for a minute. Then we also have a squid cache on top of that, so we cache it even harder. But yeah, seeing these messages in the logs from time to time, that's not nice. You know there's people sometimes that have to wait this long, or probably they're already gone by the time the page is done. So yeah, you see this log message kicks in after 10 seconds, and that might be configurable, I don't know, but even 10 seconds is not acceptable, I'd say, not in 2016. So we needed to do something about this. And to do something about this, we need to get into the engine. So there's going to be some diagrams and code from here. This is, I don't know if you're all using SDK, but since we've been using Magnolia for 6 years, we are an SDK. We're not doing the light development yet, or maybe just small projects right now. This is just a class diagram of some of the classes in SDK, and you see that at the bottom, it provides several different view models that you can use for your pages. So you might have a calendar page and it gets rendered by a calendar model. And you see there's a few overview models as well. There's a news overview model and an event overview model. And those are the models that aggregate content and create those pages listing other pages. And how does a page like that do it? Well, let's take a look at the template for it. This is from SDK's own news overview template. There's apparently a pager that it gets from the model, and then the list of news items is extracted from that pager by calling page items, and then it gets converted to a content map. Okay, great. That's apparently how the content gets onto the page. So that pager, how does that get created then? Let's go take a look. Then SDK, there's a thing called SDK Pager. And apparently that's a thing which has items. Okay. And how does it get its items then? We go even deeper. I'm like a human debugger right now. I'm stepping through some code. And then we find this method called getItems, and it's like a 4-step pipeline in here, and it's a pretty important thing to understand, to know where those 60 seconds or more went into. So first thing is we're going to perform a search. So we have our big tree of pages, tens of thousands of pages. We want to search which pages to list on this particular page that's being requested. But then a few more things happen. We're going to filter this list by some criteria we don't know here, but this is what happens. Then there's some sorting going on afterwards, and then the list gets shrunk because apparently we don't want to see all of it. Okay, that's interesting. Let's go deeper into this. First, that search. Let's see how that search works. We end up in a class called template category util, and it does some query building. It says a select star from NT-base, has this path, maybe some kind of template property, maybe some ordering, and we call another method with this query string. Okay. Might be interesting to note here that the max result size at this point is set to maximum integer, which is like 2.1 billion or something. So it's not really a small result set yet, if you have a big site. Then we're getting into this, and this is where the search is actually executed. Luckily, Magnolia has indexes for its content, so it uses Lucene, or actually Jackrabbit uses Lucene, which makes these queries quite a bit faster, so that's a good thing. But then we have a list of content nodes. Okay, great. Oh, and then comes the filtering, right? Step 2. So in this case, we have a news overview. We want to sort it by date, and maybe not show news that's in the future because that's not really relevant. So there's some date checking going on here. That's the filter. Okay. Then we had sort. That was step 3. Step 3 here is doing an ascending sort by date. Okay, that makes sense. If you're going to show news articles, show them by date. And then step 4 was the shrink. So it says if the size of the items list is bigger than the maximum results, we're going to shrink it and we're going to take a sublist. But actually max results, remember, was 2.1 billion, so you're probably not going to run into that. And actually there's a step 5, because in the template it also said get page items. And get page items, that says, I only wanted to show you 20 items or so. You might have it set to 30 or 50, I don't know. But So now we're going to take the 20 of the maybe 20,000 pages we have in our tree, and we're going to show them on a page. This all works, but when does this really become a problem? Well, I said we had 20,000 pages. Let's say we have a website called Site X, and it has a news tree of 20,000 news pages. We have this site. So we get the pager, it executes the select query, gets the pager, which now holds a collection of 20,000 nodes. We get the page items, which brings it back to 20. So we have 19,980 objects created, which we are not going to do anything with. And that's actually one of the where it gets a problem, because now you have a garbage collector going crazy, creating objects, immediately garbage collecting them again. And actually, when I found out that this is how it worked, I thought, why not do all the things? Do them all at once. Because actually, JCR queries are pretty powerful. We have the 4-step pipeline that I just showed you, but it's all implemented in Java, except for the first step, the search. Why don't we do the searching, and the filtering, and the sorting, and the shrinking all at once? So translating the example we just had into a single query might look like something like this. I didn't actually test it. Maybe there's an error in here. I don't know. But so let's take the search. This was the select that was in the search just now. Convert the filter. Just make an extra clause on the query. It can do sorting, ordering by date in this case. And it can do paging. You say we only want 20 items, and we don't want it 21st because we're on page 2 of the overview. And this returns only 20 nodes, so that's great. But then you have to go write these queries, and since you're not going to write a query for every visitor that comes by, you want to automatically create those, and then you might think, okay, I'll do string concatenation and build my queries like that. It's actually not a really great idea. And we have this great language called Java, and it's type safe, and it has these classes. And what if we could do something like this? I don't know if anyone of you ever worked with something like Hibernate or another ORM framework in Java, but this might look familiar to you. For instance, Hibernate and I think other JPA frameworks nowadays have these criteria APIs, and there you can just build your queries using Java code. So you can say, I want to search under this base path for site X news, and I want to restrict the result set to only have news template items, and I want them sorted by date, and I want to have them in ascending order by date, and I want to have this paging. Well, it would be really nice to have, right? No? Yeah, okay. We have a fan. Well, luckily, so search, the filter, the sort, and the paging again. You see the same structure again. And luckily, this already exists. Actually, it has existed for a few years. Is anyone familiar with the Open Minds modules for Magnolia? So there is a Criteria API for Magnolia CMS module that we actually used when we were on Magnolia 4, 4.4, or 4.5. We were already using this code, and it was a Magnolia module that you could just install like any other module. But then they didn't update it for Magnolia 5, and we were kind of bummed because we wanted to go to Magnolia 5, and we wanted to have our nice queries. And then we thought, well, actually, if these guys are not going to update it for Magnolia 5, well, we can do it ourselves. And actually, it's not really a Magnolia module because it's only providing like a library. It would be like any other jar that you might add to your Magnolia project, like if you're going to I don't know, write some CSV files, you might import some CSV library into your project. It doesn't have to be a Magnolia module. So we kind of took the Magnolia code off the code. We took the Magnolia dependencies out of the code, and we published it on GitHub as a JCR Criteria Project. I'm not taking credit for writing this. It was completely done by the OpenMind guys, but we wanted to keep on using this code because it was really useful to us. And so you can use this, and it just depends on JCR. So any other JCR project, you could use it as well. We haven't tested it. Let us know if there's any problems with that. And what can you do with that? Well, you still need to connect it to Magnolia somehow. Even with the old module, you need to write your own code to use these capabilities. So we decided, well, that pager, we need to change that pager because we don't want to have a pager with a collection of 20,000 nodes in it. We don't want to construct these big collections of objects. So we created our own pager, added generics while we were there, and then created our own list model, and we call it VTK for VPRO Templating Kit. And what this does is create our pager, execute it, and then our models get to implement the create pager method. So for instance, a concrete example from our code might look like something like this. I just copy-pasted the code we just had in there, but so we set the base path, we have the template restrictions and everything. Then we create a collection of nodes from the result, and we hand that over to the pager, which now only has 20 nodes in it. We thought, well, we solved it, right? We didn't create the 90,980 we didn't need. Our performance problems must be over. And in the process, we actually gained a nicer syntax. So we tried it again. Damn, it's still slow. What did we do wrong? So we weren't done. Why weren't we done? So I fired up my debugger again, put in some timing breakpoints, profilers, whatever. And what did we find? We went back to this code we just saw, and where did the time go? This call, get total size. I just wanted to know how many results are in the results, because I have to show the visitor, hey, we have more than these 20 pages that I'm listing right now. We have like 590 something more pages of content. So I need to know how many results there are in the total tree. And why does that take all the time? I just did the query. Just tell me what the number of nodes was. Now we go even deeper. This is in the JCR criteria code, and I found this, which I didn't write. I thought it was totally weird. I kind of highlighted the sections. The first section tries to get the result size from the query result, but it says if it's -1, well, -1, what's that? Okay, apparently Jackrabbit returns -1 when it says I don't really know how large this result size is. Okay. And then the code even tries in another way, and then if it's still -1, then we're going to do query counter as int, which seems pretty harmless, but actually that was where we ended up, and that was the thing that ate all of our time. Things got weirder and weirder. So we had a look inside Jackrabbit. What's going on here? Well, apparently the total size call is calling the get results, and that thing executes the query, which is a query against the Lucene index, so that's fast, great. And then afterwards, it wants to get the size, but like it says in the comment, it doesn't use the size that came from the result. It goes to call another method, and that other method goes to do security checks. Because yeah, maybe the node in the results, maybe you're not allowed to see it, so we have to check it. So still in this method, we're going to create 90,980 objects we don't need. Thank you. So just as we were about, I understand why this happens, because of course, if you're going to have a security mechanism, it might not be what you want, that somebody accessing your repository is able to see how many nodes are actually there when they're not allowed to access them. But when we're listing pages on public websites, this is not really a concern, at least not for us. So we got ready and said, okay, we need to patch this class. We don't want to do this thing. We just want to get result.getSize and be done with it. And just as I was ready to open my IDE and write this patch, we found this Gyro issue in the Jackrabbit project, which from the title didn't really seem relevant at first. It says something about Jackrabbit 2.5 having some particular implementation for node iterator getSize, and then apparently it changed it in Jackrabbit 2.6, and we're on 2.8 because that's what comes with Magnolia 5.4. And then it says, yeah, there used to be a size estimate parameter, and Jackrabbit used to do an estimate of the result size, which sounded like, oh, that's probably fast and what we want. So I looked into the patch, and yeah, actually it was what we wanted. And actually, it says here, it's already committed into Jackrabbit. So okay, well, let's just use that then. Jackrabbit is really a bit sloppy with their Gyro use because it says fix version none, well, which wasn't really true. They did fix it. They just didn't tell me with what version they did it. But apparently I found after trying newer versions, they changed it in Jackrabbit 2.10. And then the get result size, well, it's a pretty long method. I don't want to bore you with it all, but the kind of where it comes down to is, well, if the size estimate is turned on, then we're going to use the Lucene results, and we're not going to bother with security checks, and we're not going to bother with creating all those objects. So that's what we did. We upgraded our Magnolia project to use Jackrabbit 2.10. We updated production. Actually, there's one little catch. You'd never find this if you didn't read the Gyro issue, I think. But you have to enable this size estimate property in your repository XML and in your workspace XML files. After you've done all of this, yes. Our news overview sites suddenly went from 60 seconds to like 1 second, or sometimes even faster. Bingo. Luckily, the problem wasn't in Magnolia, so we don't have to blame the Magnolia guys. We can blame other random guys that we don't know working on a nice open source project called Jackrabbit. But apparently, actually, they already fixed it. And I've already talked to Magnolia, and they're going to upgrade Jackrabbit. They were already planning on upgrading Jackrabbit for Magnolia 5.5. Doesn't mean you can't do this today, because we already did it and our sites are still working. So I'm not going to give you any support or anything, but you can believe me, it works. So that's great. And actually, I'm also going to be thinking about what of this process might be usable for everybody using Magnolia, because it might be tricky to just say, oh, we're not going to use those security checks anymore anywhere. You're probably going to want them somewhere, but not in this case. At least we didn't know. We didn't want to. So I hope this was interesting and maybe useful for some of you, or might get useful if you have built up 20 years of Magnolia archives. Might be that's 20 years from now, so maybe we'll have completely different problems then. But yeah, I'd like to thank you for your attention, and if you have any questions.